Okay, question 5. The graph is showing the variation between the applied force and the compression of a spring. So the question asks how much work is done by the applied force to compress the spring by 0.1 meter, and then how much, sorry, this is work, and then this one is elastic potential energy stored in the spring when it is compressed by 0.3 meter, assuming the spring is compressed below the proportional limit. Okay. So now, remember for work, the equation is F times dengan the displacement. Okay, so for this case, since given is the applied force and compression, we can actually just calculate the we can actually just calculate the area under the graph, because it will tell us the value of work done lah. And for this case, we can calculate it from here to there. Yalah, 0 to 0.1. Sebab soalan minta by 0.1 meter saja. So that is half fx. Force is 2x is 0.1. So dapatlah jawapan dia 0.1 joule. Okay. So every time there's a graph and the graph is force against compression, something that is related to displacement, you can actually just calculate the area under the graph lah, because it will tell you the value of work done juga satu kali. Okay. Okay, so now we have to calculate the potential energy. Okay, sekarang ni potential energy untuk kalau cara kamu kira is for a spring, it is U equal to half kx square. Sekarang ni x ni kita tahu kita perlu substitute dia equal to 0.3 meter. Tapi sekarang ni kita tiada value k. So macam mana kita cari value k? Based on this graph, we can actually obtain the value of k by determining the gradient of the graph. Okay, so cara kita mencari the gradient of the graph is just tiga segi macam ni lah. Okay. Besar juga kan kita buat. Actually kita boleh buat gini juga. Kita buat gitulah. So this is your gradient. So we can then use the gradient, which is equal to the spring constant, which is equal to 4 minus, you can write delta y delta x, I think. Boleh lah buat gitu pun boleh. 4 minus 2 divide by 0.2 minus 0.1. Okay, so dapatlah 20 Newton per meter as your spring constant. So after dapat spring constant, we can then calculate the the elastic potential energy. I'm actually eating candy now, that's why I can't really talk properly. I'm sorry. So kamu akan dapat jawapan dia 0.9 joule. Okay, that is very straightforward, except for the part where you calculate the gradient na kali. Because kalau kamu ingat, F is equal to kx. So k is equal to F over x. So that's why kita boleh guna the gradient of this graph untuk cari k. Sebab formula dia F equal to kx. Macam tu. Ada negatif di sini, tapi tidak payahlah. Okay, so that is the solution for question number 5.